contain neurotransmitters. Where were these produced? These were produced back up in the cell body. There's something called axonal transport. You have little microtubule proteins all the way down through here. They grab a hold of a vesicle and they chug, 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 move it like down a train track down through here. They can grab things here and transport them back. If it's transported from the cell body to the terminal here, it's called anterograde, which literally means going toward the front, right? If it's transported backwards this way, it's called retrograde backwards. So it's just showing you, in my big toe, there's one of these with acetylcholine in it. Where's the cell body? About right here. That means what? I had to get this vesicle a meter all the way down to my big toe so it could stimulate muscles to contract. So how do you do it? Anterograde transport. It's actually pretty quick. Down through there. Sometimes do we have things down here we have to bring back? Sure, absolutely. So we can go back and forth. But what we need to have happen is when an action potential depolarizes the membrane here, the neurotransmitter vesicle needs to bind to the membrane and release the neurotransmitter. Exocytosis, yeah. Complete or partial even, right? Complete exocytosis would mean it binds to the membrane, opens up, and the vesicle's gone, right? It stays with the membrane. Partial exocytosis would be bind to the membrane, open up a little bit, leak some out, membrane come back together, pull back. It's actually called kiss and run, which reminds me of 4th grade, but that's a totally different story. All right. So what does this look like? Well, it looks kind of like this. If you were to look at the membrane around a vesicle, it's got a lot of proteins in it. You know, fluid mosaic, just like anything else. If you were to look at the membrane here on the axon terminal, it's got a lot of proteins in it as well. Nothing special there. Some of the proteins that are in it are called docking proteins, and they're complementary, meaning they have what? Affinity. Thank you. They have affinity. And they'll want to bind to each other. And if their affinity is really high, they'll bind. And when they bind, this is what happens. Let me show you. I'll draw one back now. They look like this when they bind. They look like that. Okay. And so when they're bound, what happens? They open. And when they open, what comes out? The neurotransmitter. So these proteins are called docking proteins because the vesicle docks on it, right? And they have these little, called snare proteins, or just these little arms that stick out, that when they get close together, they latch, like this, just like latching on, like 2 hooks or something. And then once that happens, they open up. And they can do one of 2 things at this point. They can open up all the way, and guess what? This vesicle just became part of this membrane. And we have released all of the neurotransmitter in there. Or they can open up a little bit of neurotransmitter comes out, close up, retreat. That's the kiss and run. Okay? They could go open up, release a little bit, come back. Now what's the significance of the 2? Well, it has to do with the amount of neurotransmitter, right? A strong stimulus, a lot of neurotransmitter, probably full exocytosis. Weak stimulus, a little neurotransmitter, probably kiss and run. The other reason that you wouldn't want exocytosis of everything is that would be too much neurotransmitter, none left in here. Then you have to go make some more, right? Transport it back down here. So we don't want to have this flood of neurotransmitter, which is what happens with cocaine, ecstasy, things like that. They trigger a massive exocytosis of neurotransmitters that are normally released slowly. So the result is massive stimulation out here, and euphoria, if we're talking about, you know, ecstasy, cocaine, those kinds of things. A post-high depression, necessarily because you don't have any what? Neurotransmitters. Life ain't fun after the day after a rave.
It's the serotonin and dopamine, right?
Serotonin and dopamine are the two common ones, absolutely. Both cocaine and ecstasy trigger a flood of dopamine and serotonin. You saw that on TV? So what do we need to have happen? We need something to, do we want, with an action potential, higher or lower affinity? Higher affinity. So no action potential, weak affinity. Action potential, high affinity. So we need to change the structure of these proteins, right? Now, protein folding and structure is dependent upon local environmental conditions, right? Make sense? If you change the environment of a protein, do you change its shape? Potentially, yes. So, what is going to affect the structure of this is calcium. Okay. So, without calcium, weak attraction. With calcium, strong attraction. So no calcium, no neurotransmitter. Calcium inside here, neurotransmitter. Is there normally much calcium in the cytoplasm? Some, but much. I guess if I'm asking the question, ECF or ICF, which has a greater amount of calcium? ECF.